So hello everyone, welcome to Global Math Department. We are all set up for our meeting this evening and we are starting right on time. My name is Paula Torres, I'll be your host tonight. And tonight we are going to hear from Mr. DeltaMath himself, Zach Korzik. Would everyone go ahead right now and start to introduce yourselves in the chat window, telling us what you teach, where you teach, and feel free to pop your Twitter handle in there if you have one and you're willing to share it. Hi, Teresa. Hello, Michelle. Hi, Kate. So while everyone is finishing up, I just want to tell you a little bit about Global Math Department and how the webinars work. They are recorded and usually available a couple of hours after the webinar is over. So if you would like to come back or strongly encourage a colleague to come and watch this, know that they can get in the same way that you did through the main page. The Global Math community prides itself on being friendly and supportive, so know that that chat room is available for topical and general conversation. If you have questions, you should notice that at the top of the chat window, there are some different tabs that say chat, Q&A, polls, and handouts. We would prefer that you actually put your questions in the Q&A so that we don't miss them. But know that I am paying attention to the chat window, so if you forget, I will catch the questions. So without further ado, Zach is our speaker tonight, and know that he is the creator of a website called DeltaMath, used by hundreds of thousands of teachers and students. He's also a full-time teacher at Manhattan Village Academy and a Math for America master teacher, currently teaching AP Calc, AP Computer Science Principles, and Pre-Calculus. He also spent the previous 10 years teaching Algebra 2, and you can find him on Twitter, easily enough, at Mr. DeltaMath. So without further ado, I know he has lots of good things to show you. Take it away, Zach.
Thank you. My name is Zach. Wow, I can hear an echo of myself. How do I stop that? Okay, I'm doing much better now. Okay, so welcome everybody. My name is Zach. I made this website, DeltaMath. It is a free website for teachers. Right now, what you're seeing is the teacher homepage. So first thing I'm going to do is show you the different kinds of problems that DeltaMath has and that you can assign to your students, either as homework or as classwork. And then I'll show you guys how to make an assignment and how to look at student data. So first thing you should know is that these are all categories and they're listed basically by grade. So middle school Algebra 1, Geometry Algebra 2, Pre-Calculus, Calculus, and Computer Science. So each of these are categories. So if you were to click linear functions, you would see a whole lot of different problem types for linear functions. If you wanted factoring, you could type factoring, and you would see a whole lot of categories that had factoring in its title. And these are only the skills that have factoring in its title. If you were to click that, it would expand it to show you everything. So if you could click into a given type, like factor by grouping. So the idea is each of these problems were randomly generated of a given type, guaranteeing, for example, here that factor by grouping would work. As the teacher, you can press new problem as many times as you want just to see a variety of all the problems that are available. If you click show solution, you can see what the solution looks like for each of those given problems. Now, if the students were solving this, since there's basically infinitely many versions of the problem, the students can keep solving until they understand what they're doing and get a sufficient number of problems right, as determined by the teacher. If the student gets the question wrong, they're able to see the solution here. They're not really able to click show solution right away. This is just the teacher page. You can also see a little question mark here for factor by grouping to see basically the accuracy, overall accuracy on this problem and average time to solve for a problem statistically on the website. If you click easiest problem, you see that this is the question which students found the easiest of all the possible problems that could be there. And if you click hardest problem, it was this one. You can see because probably there was a difference of squares after the initial factor by grouping. So I am going to start off by just going through some of the modules that I think are most impressive that teachers may want to use. So I have a bunch here. So this one is geometry. So it's basically the students are allowed to drag the vertices of the triangle until something is true. So this says drag the vertices until it forms an isosceles obtuse triangle. So the way this is designed is basically it's not super like proofy, but things click into place. You can see it click into place a little bit. So now an isosceles triangle would be sort of where that vertex is along this sort of line, which is a perpendicular bisector. But in this case, it's not obtuse. That's an acute angle. They keep dragging it in, then it'll click here to be an isosceles right triangle, but their job is to do it until it's isosceles and obtuse. So any version of that triangle would be fine. They could submit it, and it would grade them. It would show them their triangle, and it would show them any possible triangle. And the students would click new problem, and now it's scalene obtuse. So you'd probably have scalene, obtuse, right, and acute, and then isosceles, obtuse, right, and acute, and then an equilateral triangle. Another kind for geometry would be basically identifying angles. So if I say angle EBA, I see an image here, and I see the E, I see the B, I see the A. Zoom in on there. And you see these little dots, and those little dots allow them to kind of drag the angle. So obviously, this would be EBC. Here we'll go EBA. And it's going to grade them based on whether that was an accurate representation of that angle. And in the solution, it will show them a little outline of what EBA should have been. This is another geometry one. So the students are asked to play with the figure. So all versions of this problem start with a square. And as they move it around, they see certain things are always true. So certain vertices give different, basically, degrees of freedom. But what's one thing that we notice is always true? I'm showing right here the side lengths. If I show the angles, what am I seeing as I move the vertices around? I'm seeing the opposite angles are always the same. Okay, if I see the sides, this is probably the giveaway for the math teachers here. No matter what I do, the sides are all congruent to each other. So the students can measure different things like the slopes of the opposite sides. We can see opposite slopes are the same. They can check the diagonals and how the diagonal lengths change, such as AC and DB. And then they can slide over here what they believe, what they noticed is always true. So this isn't actually having the students classify yet, but it's just having them practice that sometimes sides are always parallel. Sometimes all four sides are congruent. So this is a good way of starting the idea of properties of various quadrilaterals. This is one that I just recently made for trigonometry. So how can we solve the equation sine of theta equals 1/2 for 0 to 2 pi? So originally, actually, there's no type of line showing. The students should know that sine represents a y-coordinate on the unit circle. So I want to find all points that have a y-coordinate of 1/2. So the students will realize that in order to make a line go through those points, I would need a horizontal line. So for example, this line is going through all points on the circle with a y-coordinate of 1, but that's not what I'm looking for. I'm looking for all points with a y-coordinate of 1/2. So if they drag it down, they see the two yellow dots, two intersections with that circle. So those two intersections now have a y-coordinate. We can see it right there, of 1/2. And then the students will get accustomed to the fact, once you've taught them about reference angles, that these three angles here are 30, 45, and 60. That's in degrees. And down here, I'm actually having them write it as degrees and as radians, because I found it helpful for the students sometimes to write it as both so that they kind of make an equivalence between them, because some students still can't get over thinking in degrees. So it might help ease the transition if they're constantly writing the answer both ways. And then here we notice that this is a 30-degree arc, but it's subtracted from 180, which would be 150. And the radian would be 5 pi over 6. So to get the question right, the student has to drag the line to the correct place and determine the angles properly. I'm going to take questions at the end when I'm done going through some modules here. Okay, this is an example of geometry as well. So use a compass and straight edge. I just recently made this at the end of the summer, beginning of September. So I wanted it to be more like a real compass is. So how you would do it is you select the compass tool, and you can click and drag in order to make the center and outside. Afterwards, you can also just change it if you don't want to click and drag. Okay, and it sort of clicks to the various things, so that it would click. So to make an angle bisector, you'll see now as I hover over the circle, a pencil appears. So I can actually draw an arc like I would with a real compass. Okay. Now, of course, they can just draw the full circle, but that's fine. It doesn't matter as long as they have an arc. Okay, so our goal is to make an angle bisector here. So then we would drag this, and it would click there, right? And then this one, I just have to make that a little bit wider somehow. Okay. So if I draw an arc here, and then I move the center, but I do not change the radius, and I draw an arc here, a little dot appears right there. Okay, that dot is the intersection of the two arcs. And to make a bisector, the student would click ray, and they would click and hold and drag, and it would lock in. So this is a perfect angle bisector. And when they submit, they say, yes, I'm sure I want to submit. And then they see the check mark, which means they got it right. Now, this is the solution. So if a student doesn't know what to do, they can actually press show example. I'll show you that later. If we press next, the student can see a little play of how the angle bisector should have been made. With a little explanation, like center the compass at the point of intersection, no need to change the radius. Arc, this says do not change the radius here. Arc, and then ray, and now you have bisected the angle S. And you as a teacher, when you are looking at the student data, you can look at the students and you can click on a student who got one wrong. You can actually see what they did. You can see what their final construction looks like. And I can only imagine, I haven't taught geometry, but trying to grade constructions can probably be a little difficult. This does look good, but if you press start over, and you can click and you can actually see exactly what the students did. If the students made the whole circle, you'd see that. And then at this point, you can see it says the student dragged the center and kept the same radius. So you could actually see there if they had moved the radius and made it look basically like a bisector, but if they moved the radius, it would not be accurate. So it's grading on accuracy. The students can complete the construction in any mathematically accurate way, and it would give them the credit. And I have 18 different types of constructions, but I just decided to show this one. This is one for combining like terms. So we see a bunch of terms here. Some of them are like terms, and some of them are not like terms. And the guided version here actually is interactive, and it lets the students drag. So they can actually click, pick up the term, and try to drag it onto another term. So if I try to drag it into this one, it's going to say, hey, negative 3x and negative 2x squared are not like terms. The terms must have the same exponent. Okay, so let's try again. So let's take it and drag it onto this. So those are like terms, and they're allowing the student to write the result. So let's say they mistakenly thought the x squareds would go away, and we write 4. It's not letting them. It's saying those do not combine to 4. Try again. So this is a guided problem. So the students would keep typing until they get it right. Once they get it right, that term changes to 2x squared, and then they would continue dragging like terms until they had as few terms as possible. And once that was true, they would be able to submit their answer and get credit. If it's a guided problem, they can't really get the question wrong. They just have to keep trying with feedback until they succeed in the problem. This one is for ratios. I have a few different things for ratios. There's a lot of middle school that I want to add. As I said in the introduction, I'm a full-time teacher. I started the website 9 years ago, and there are more content that needs to be added. So I think middle school is doing okay, but there's a lot of things I want. But this is a cool one that I think shows equivalent ratios. So 36 to 24, any equivalent ratio that could actually be split into groups here. So if I divided each of those by 2, it would be 18 to 12. They could try that, and they could see, well, yeah, I could make groups of 18 boys to 12 girls, and I could make 2 groups of that. If I tried to do, let's say, 9 to 6, then it would try, and that was actually good. I was trying to show one that doesn't work, so maybe 6 to 3 would not work. So it would show that, in fact, we have these extra pink ones, so that doesn't work. So this would be a good way of having students visualize how ratios can be expressed with like lower numbers, but still the same kind of ratio. I just recently made this one on linear functions. So It's a word problem, and a lot of the ones I've been adding recently have been kind of like make a sentence using drop-down boxes. So in this example, Evelyn has joined a frequent coffee buyer program with a local cafe. The program is $5 per month, and then she can get a discounted price of $1.50 per cup. Answer the questions regarding the relationship between the number of cups of coffee purchased and the total monthly cost. So the independent variable is, what would it be? So the number of cups purchased or the cost? So typically we would say that the number of cups purchased is the independent variable and the dependent variable is the total cost. And the reason is because the total monthly cost that we have to pay depends on how many cups of coffee we purchased. Okay, so then the student's asked to, assuming X is number of cups of coffee purchased, it's $1.50 per cup, but recall that there's a $5 flat fee just to be in the program, which would be our constant. So this is an example of a student getting it right. So then let's do an example, right? So I am telling them to evaluate their function at a number of my choosing. So I plug 15 in there. I think we get 2750. So what does this mean? The students have to interpret, meaning 15, is 15 the dollars or 15 the cups? Well, if the student gets that the independent variable is X, and that's 15 is the number of cups. So meaning 15 cups of coffee will cost $27.50 monthly. So if they submit it, they see in blue all of their decisions, what they decided to type in, and then they can see the correct answer and what an ideal sort of paragraph would be as an interpretation of the function that was described to them in words. Okay, a few more here. Going up to Algebra 2 and trig graphs. So I do have some, by the way, I'm showing all the really fancy ones, the ones that have interactivity, the ones that have animations, the ones that look cool. And that's just my decision. You remember the first one that I showed was factor by grouping, and it was very straightforward, and it was just 2 or 3 steps each time. So I also have a very straightforward version of trig graphs where the students are just shown a graph and they have to type the equation. And if it's not right, they don't get credit. If it's right, they get credit. But this is one of those discovery/guided questions that I was talking about earlier. So in this case, the students can play with the parameters. So their graph, the solid graph, is a sine graph. Notice its maximum is 1, its amplitude is 1, its period is 2 pi. So the student's goal is to get the graph to match the dotted graph here. So they can play with the parameters here. So let's say they made a 2 in front of the sine and pressed try or enter. You would see a little animation here making the amplitude 2 while the midline would stay the same. So if we make that back to nothing or to 1, and it goes back to normal. If we make that -1, we see the graph goes down 1. If we make it +3, we see that it goes so that its starting position on the y-axis is 3. And if you've taught this before, you know that that's a good strategy to start. So if students are doing this module, if they do 5 or 10, they'll start to get the hang of, okay, well, why don't I start with this number to make sure that that matches this y-intercept? And that's kind of the concepts you want students to develop when they're trying to solve these problems on paper. Okay, so I need to make the graph taller. So I'm going to make this, if I made it 3, you'd see it went too big. If I made it -2, you'd see it flipped upside down. I believe the amplitude is 2. So now it maxes at 5 and it mins at 1, but I have to play with the coefficient of x in order to make the period work. So we know that if I type a number next to x, 2 times x, the students may assume that the graph would stretch horizontally, but they'll see via experiment that it compresses. That was a compression by a factor of 2, and I believe the total compression would have needed to be by a factor of 3 here. And you see that it all clicked into place when it was correct, and they can submit the answer and get their points. And then sort of a little visual representation saying, hey, this is what an amplitude is, by the way. This is what a period is, by the way. This is what a midline is, by the way. Maybe those are some vocabulary you want to start using when trying to figure out a quicker way of figuring out what the equation should be. This summer I made matrix multiplication, and I just learned a lot about it myself, and I decided I wanted to make, I think 50-something modules with vectors or matrices. This is one of the ones that is a little bit more conceptual. So multiplying a matrix times a vector. I knew how to do it. I learned in college how to do that, but I don't believe I really understood what it meant visually until I researched this, and then I created this module. So for those of you who don't know, this is a matrix. This 3, -2 is sort of a vector, and this 2, 1 is a vector. So the students are asked to drag the vector 1, 0, which is this u here. So to drag that in order to overlap this vector u, okay, which is the first column here. So I want to drag u. I can drag this vector, and the coordinate plane stretches. I want to drag it to be overlapping here with 3, -2. And then I'm going to drag v, which is, 0, 1. And drag that to overlap 2, 1. So what you actually see is basically kind of a new warped coordinate space where I can count by u's going in this way, and I count by v's going in this way. So matrix multiplication is to first warp the space like this, and then the -2 is just how many u's to go. So -2 u's would be actually, if u is this way, negative u is this way, okay? So I'm going -2 vector u's here, and then 6 is going in the direction of vector v, which is this small little vector in that direction. So -2 u's is here, then 1, 2, 3, 4, 5, 6. This is basically the coordinate. If you kind of turn your screen or turn your head, it kind of looks like a coordinate system that you can see that's where I want to go. So the instructions are to click from the origin and drag a vector into the appropriate location, which would be -2 u's plus 6 v's. If they do it wrong, they're going to get a little feedback and say, make sure it was exactly 2 -u's and 6 v's. So then they would just attempt it again until they got it right. And when they got it right, it said, well done, you got it. This is guided, right? So now we're going to reset the coordinate system. They click that button, and they see, hey, where in fact is that, right? 2 -u's and 6 v's. If I were to be in my original coordinate system, and it looks like it's at 6, 10. So actually, that is the answer. If you try, that's correct. If you multiply these using the standard algorithms, you get 6, 10. But this really shows the reason why. And the students are actually also asked to sort of say, all right, we'll distribute the -2 times this vector and the 6 times this vector, and they can sort of understand an algebraic way of solving it as well. And I believe I have to show my calculus. Last year, I taught calculus, AP calculus, for the first time. So I developed around 200 of these problem types in calculus last year. So, last year I'd already been making the site for 8 years, so I'm getting a little bit better at this. So I was able to make some of these really interactive. So I wanted to show the students a graph of f, and then I wanted them to draw, you can see, draw a graph. Now, if they're drawing and they mess up, well, they can start over. If they start over from here and click, then it just starts from there. So they don't erase their whole graph. And if they kind of back up, so I'm clicking and holding right now. So in calculus, we see if our graph is increasing, that our derivative should be positive. But if our graph is concave down versus concave up, our derivative here is concave down. That means our graph is but increasing. So the graph is positive but decreasing. So I'm going to be positive. Whoops. I'm going to be positive but decreasing till I get to 6. I should actually touch 6 because that is a horizontal tangent line whose slope is 0. And then I'm going to be my derivative is concave up, so my derivative increases all the way to -3. And then I'm still increasing here, so my derivative is still positive, but my derivative is now concave down. So it's going to be positive all the way until 0. The reason it's 0 is that f starts decreasing now. My derivative has to be negative. So it's going to be negative all the way down to -2. And it was decreasing, but now I'm concave up again. So I have to sort of increase all the way to 7, 0. Since at x equals 7, the graph is a horizontal tangent, they keep going. So this is a miss right here. I hope that's, sometimes I'm lenient here. So yep, so they're actually going to get it wrong here. They're going to say their x-intercepts were not correct. You only plotted 0 and 7. So I should have been a little more careful when I was drawing it. But the student is able to see what the derivative should have looked like as compared to them. And as long as their graph is decreasing and increasing, and also positive versus negative, and has the correct intercepts, then their graph should have been marked correct. And the explanations are showing on each interval, the student can change that the F is increasing and concave down, so F prime must be decreasing and positive. So they're able to make the connections that they learned in calculus class. And the last kind of problem I want to show you is timed problems, which are a little bit different. These timed problems are supposed to be really quick. So they just click the answer as quick as they can, just to get the hang of something. So things that I make timed sometimes are ones that a student could kind of just cheat, I guess, by using a calculator. So if you give this problem to a student and you say, okay, do it in your head, well, they might use a calculator. But if you make them do 10 in 100 seconds, and the teacher can change, and I'll show you how to make assignments later, the teacher can change how many seconds or how many problems they want the kids to do. By the way, that would be number of problems in a row that they have to get correct. Then they can just start over if they're having problems. But this shows a little bit of what the answer should have been if they get it wrong, and then they can keep trying. So this is excellent practice. That was in this mental math. I have a lot of things, just adding integers if you want. You can just press start and stop to see a bunch of different problems and what they look like. That's all in middle school. It's just kind of basic things that may be good for kids to be good at. Okay, I'm going to see if there's questions right now. Is there anybody has a question so far? I'm in the Q&A. Okay. All right, so why don't we get to the interface and how you make an assignment, how you make an account. So what you would do first is you would go as a teacher to deltamath.com. You would click create account, and in there you would click create a teacher account. It's going to make you type your name, your email address, and it's going to also ask you to say what your sections are, like what they're called. So for example, period 1, 2, 5, 7, and 8. Okay, and then you would see. Then you would sign in, and everybody has this page. Now, I'm actually signed into my account so that we'll actually be able to see some data. But here we go. So how do we make an assignment? You will have to make an assignment because if the students sign in and you haven't made an assignment, then the students will see nothing. So DeltaMath is required that the teacher make an assignment for their students to do. So the way I do it as a teacher is, if whatever I'm teaching this week, I will teach it. And then I will put up one assignment every week, and then the students will complete it, let's say by Friday. And then on that day that it's complete, I will give them a quiz or a test. And then usually they feel very confident on the quiz or the test if they've completed the DeltaMath assignment. So that's the pattern I use. If I make it do every week or twice a week, then if a student is difficulty finding a computer or the internet, then they will be able to, make plans to make sure that they can find a place. This website is mobile friendly, so if they have a phone, all the interactive things should work. Sometimes it's not as convenient to do some of the interactive ones on a small phone, but from what I see, lots of people do DeltaMath on their phone and they can succeed at it. It is not an app in the App Store because I don't have time to make a specialized app, but it is mobile friendly, so when the screen shrinks, the content shrinks with it and everything fits right. So the first thing you're going to want to do, besides for just explore, right? So you're just going to want to see and what's here, what am I teaching, right? Start searching things, looking things up, percents, right? This is all middle school stuff. You can see that these are all categories: geometry, algebra 2, pre-calculus, calculus, and then a little computer science, which I taught there. Okay, so what you have to do is click Create Edit, and then click Create Standard Assignment. Okay, so what happens is there's this side panel happens, and then you can type in my first assignment, whatever you want to type. Now, when you made your teacher account, you will have said what your periods are, and maybe you didn't call them periods. You're allowed to call them sections. You're allowed to call them classes, but you should type in the names of those. The reason is because when you register, you will be given a teacher code, and you need to tell your students in your class what your teacher code is. I'm going to show this a little bit later, but they will type in your teacher code, and then from a drop-down box, they will select the class that they're in, but they'll be reading the classes based on what you typed in as your classes. So it's important that you make them meaningful. So my students knew if they were in period 2 to pick that. If they were in computer science to pick that. If they were in AP Calc, they picked that. But for the purposes of this webinar, I'm going to pick test. So what I'm doing, and I'm making an assignment, and only students who are in this period test, will be able to see the assignment that I'm going to make. And by default, I'm going, and you can hover over the question marks if you want to see what certain things mean. By default, the assignment goes up right away, which means if a student signs in 5 minutes, they will see the assignment that I made. You can say later, which just means I'm making the assignment, but I don't want anybody to see it yet until I edit it and change this back to immediately. Or I can say, let this go up tomorrow morning at 8:20 in the morning, and then it will only be visible then. And then you don't have to do anything. It'll just automatically be visible at that time. But I'm going to say immediately. So that's the first tab. It's just the basics. The skills is what you want your students to learn. So each of these is skills. Now there's 1,200, a little bit more than 1,200 different skills that you can assign. Okay. So I'm just going to keep it simple. I'm going to type equations. So I'm going to deal with linear equations only because it'll be easy for my examples. I can click them and see what the types are. So it's basically, this is just using additive inverses. I can click a few to see what they basically look like. It looks like step 2 is just multiplicative inverse, just by dividing. Type 3, I think sometimes it gives you an answer. It needs to be in simplest form. If we look at the solution, maybe, okay, occasionally the answer will be a fraction. So that's what made it level 3. All right, so let me just say I want to assign type 1 and type 2. And then I'm going to assign a more challenging one, which is going to involve distribution, combining like terms, and then getting the constants on one side and then dividing by the coefficient of x. So if I click back, I'm right where I was. And it's actually highlighted the one I was just looking at in case you forgot. So I'm going to assign that one. And let's say I'm going to assign type 3 as well. OK, so notice that I might want to change the order. So I can change the order there. This is the order that the students will see. OK, now if I click them, I can change the settings. So these are all the different settings that I can make. So you can also click here if you forget what it is. Click there as many times as you want. You can see what the problems look like. So the most important thing to do is required, which is how many of these types of problems do you want your students to get right? How many do you want them to get right? It's not how many do you want them to try. So on DeltaMath, students will only get credit when their answer is correct. But they will be able to keep working. They might have to solve 15, 20 problems before they achieve the goal. Ultimately, their grade will be able to be 100% if they keep persevering. But there's this thing called the penalty, okay? And if we read that, it is the amount subtracted from the student's score when they get a question wrong. But their score can never go below 0. So this is the default. So the default is do 5 and the penalty is 1 off. So and I'll show this from the student's perspective as well. But what that means is if they got 3 right, now they're 3 out of 5, right? But if they get the 4th one wrong, since there is a penalty of 1 off, their score of 3 will drop to a score of 2. So their score goes down by 1 when they get 1 wrong, and their score goes up by 1 when they get 1 right. So as long as they're getting more than 50% right, then their score will increase. And once it increases to 5, they can stop. And then they can move on to the next problem type because they'll be presumably ready for that. So the idea is that students should keep working on a given section no matter how many they get wrong until they get the required score. Now, if you think that the penalty will discourage your students, or if the problem you just know for your kids is really difficult, you may want to change the penalty. So if you do no penalty, then what that means is that the students have to just get 5 right, and it doesn't matter how many they get wrong. So if they get 1 wrong and then, 1 right, 5 wrong, those 5 wrong, they still have a score of 1. Then if they get another one right, now their score is 2, and then they can get 10 more wrong. It won't matter, their score is 2. As soon as they get 5 right, ever, then they've succeeded and they have a 100% on this skill. If you want to be in between, you could do 0.5 off. So that means basically they'd need to get 2 questions wrong before their score was subtracted by 1. 0.25 is they'd need to get 4 questions wrong before their score was subtracted by 1. And the most brutal penalty is back to 0, which means if you got 4 right, you're almost there. And then you get 1 wrong and you're back to 0. So you were at 4 and then you got 1 wrong, you're back to 0. So then the only way of succeeding is to get 5 in a row correct. Now for something like this problem should really just take, 1 second or 5 seconds. I don't know. Doing back to 0 for this, for some students, would be appropriate in my mind. The first year I ever made DeltaMath, I did back to 0 a lot of times. I wanted them to get it so that they would not make mistake, so that they would learn that mistakes were terrible and that they should learn how it feels to be careful and then take that feeling onto the test. I never do back to 0 anymore, because kids can cry, things like that. But that's totally the teacher's decision. So it's not DeltaMath. You can tell the kid's not DeltaMath's fault. If the teacher says back to 0, that's the teacher. That's up to them. Okay. If we go to this, let's say that's 5, 1 off. Okay, 5, 1 off. Now for this one, you might want to say, that's a little more challenging. I only need them to do 3. So the question is, how is it scored? Okay, so what percentage of the assignment grade is going to be to each section? So the default is that every section is worth the same amount, the same percentage of the assignment grade. So since there's 4 sections here, then each of them is worth 25%. So this one's worth 25%. This is worth 25%. This is worth 25%. And even though this is only 3 problems, it's still worth 25%. And I actually feel that that's fair, because the reason you did 3 wasn't because you didn't want it to be worth as much, it's because you knew that that problem would take longer and you didn't need them to do as many. If you want a certain section to be worth more, you can press the more, and there's a little bit of a little extra that you can change here. So the weight is the weight of this section. So by default, the weight of everything is 1. So if it's 1 to 1 to 1 to 1, then everything's 25%. If I were to change this weight to 2, then the total weight would be 1, 1, 1, 2. So the total weight is 5, and this one is worth 2 out of 5. So then this whole section would be worth 40% of the assignment grade. If I made it 3, then this whole section would be worth half of the student's grade. So again, it's in the more section because I don't think you need to change that. If you're a beginner, you don't have to. But we can leave that as 1 if we want. It's a little easier to understand. Now attempts, remember I said before that there's a penalty, right? So if they get one wrong, then their score goes down by 1. Well, the default is a little bit nice. The default is if they get a particular question wrong, they get a warning, and that's an attempt. It will say, hey, that was wrong, find your mistake. And I have actually found that very effective, giving 2 attempts instead of just 1, because then the student, frantically looks through their problem to see where they made the mistake, because they don't want the penalty. The penalty would be terrible. And then they find their mistake and they end up learning a lot by seeing what their mistake is. So, if you want to be really nice, give them 5 attempts, right? What would that mean? That would mean the kid could guess 1. And then when they press submit, it wouldn't show them the solution. It would say wrong. Then they could just guess. So if you give them too many attempts, they could just guess for the first 3. So that's just totally up to you. But they would have 5 attempts on this problem before any penalty and subtraction from their score occurred. Okay, so I set up an assignment. I explained what required was, what penalty was, which are the 2 most important concepts. And then the last thing is due date. So let's just say the due date is Friday at 8:20. You can add a late date, which I'll do. So you don't have to add a late date. If you don't add a late date, any work done after the due date will not count for their grade. So if their grade was a 50 before it was due, and then the due date passed, and then they completed it to 100%, their grade would still be 50 because they only did 50% on time. Now, as a teacher, you would be able to see that the student did complete it to 100%, but that you would also see that their grade was 50, and then you would know that only 50% was on time. But if you want to give them automatic credit in their grade for any work completed late, for example, you could do 50% credit for any work done by the following Friday, okay? So in that scenario I described before, if they did 50% on time, then their grade is 50. Now it passed the due date, but it's before this week later late date. Now they're getting 50% credit on all of the rest of it. So if they did 50% on time, that means there's 50% missing. Now they completed that 50% that was missing, they're only getting half credit for it. So that means they're only going to get 25% out of the 50 that they could have got. So their total grade would be 75%. So that's how the late credit works. And you can add more. You can add 10 late dates and make it just 10% less every day if you want, but that could be a lot of work. So I'll just add 1 late date. So if you click Create Assignment, there it is. The assignment is there. Okay, so what we're going to have to do, I'm going to sign in as a student. So I'm going to sign out. Okay. We're signing in as a student account that I previously made. Actually, let me just show you what they would do. The students would click, as a teacher, you'd click Create, you'd click Teacher, and then this is all the information like Mr., whatever. You type your school, you say periods or your class, and you'd say I have 4 classes. It's AP Calc, Pre-Calc, whatever you want to do, and then you click this button. And you would get a teacher code when you clicked it. It would email you the teacher code, and it would also show you the teacher code on the screen. You should write it down because you need to tell that to your students. What your students would do is they would go to deltamath.com, they'd click Create Account, but then they'd click Student. And then they would type your teacher code. So if your teacher code is 555123, then they see your name, and then they select their period. So let's say a student is in period 8. They can also be in AP Calc, okay? So the student can select if they want, if they have you twice, then they'll see all assignments that you made for either of those sections. And they have to make an email and a password and their name, and then they create an account. And then they would type their email here, and then when they logged in, they would see the assignment that you made. So there's only one upcoming assignment because they only have 1 teacher. If they want to add a teacher, they can, by the way. They can click Tools, Manage Teachers. They can click Add Teacher, type a new code, or they can edit you and change the section that they're in. But for now, this person is only in section Test. Okay? So right now, my grade, my completion percentage is a 0%. This is the due date. There are 4 sections. I need to do 5 of these. When we made it, we said each section would be worth the same amount. So 25%, 25%, 25%, 25%. So the student would click on the first one, and then they would get a random problem, okay, of that type that you wanted. So the student can see what their score is, which is 0. They can see what the penalty is, and that doesn't matter. If I get one wrong right now, I'm not going to have a negative score. That's impossible. Otherwise, kids could dig themselves into too deep a hole. So they can also press Show Example if they want to press Show Example, Next Example, to see as many examples as they want. And these examples are different from any of the problems that they may possibly get. So in this case, the answer is -12. So they'll submit, they'll say yes, they'll see the check, they'll see the solution. Now let's see what happened here. So the score is now 1 because they got 1 right. And that's their record. The record is the highest the score has ever been. I'll explain that in a little bit. Now their completion is 5%. That's because we've completed 1 out of 5 out of the first section, which was worth 25%. So if you do the math, that means each problem is worth 5% in this section. They press New Problem. This one's 11, submit, enter, next problem. This one's 3, enter, submit, next problem. This one's 10. Actually, I get it wrong. Okay, so right now I have a grade on my assignment is 15%. Okay, now my score is 3, my record is 3. That's important. My record matches my score. This is the highest my score has been. My grade is 15%. Now what happens when I get one wrong? Okay, when I get one wrong, because the teacher was so nice as to give attempts, the student sees are on attempt 1. So that means if they submit an answer which is wrong, they're going to say, yes, I'm sure. They're going to get feedback. Your answer is not correct. You have 1 attempt remaining. Oh no, I have 1 attempt remaining. I'm on my last attempt, 2 out of 2. I need to get it right. But unfortunately, let's say that the student does not get it right. So I want you to see what happens when they get it wrong. There's a penalty of 1 off. Their score is 3. Their record is 3. They're going to go, submit, wrong, that's X. What is their score? It is 2. Why? Because the penalty was 1 and it was subtracted. But the record stays 3. The reason is I don't want students to be scared, and the grade is based on the record. So it's actually impossible for an assignment grade to go down. You don't want a kid looking at a difficult problem and saying, you know what, I have a 70. I'm going to keep it because I don't want to get a 65 if I get this wrong. So you want a kid's score on the assignment to be based on the highest they've been, but you want them to have incentive to keep working in order to make sure that that's 5 out of 5. So now that their score is 2, this is a question that new students will ask, and you'll have to explain it to them maybe more than once. Now I'm going to get it right, okay? So what's going to happen is I'm going to get this right, and my score, which is 2, is going to raise to 3 because it's at 2, and it's going to add 1. So my score will raise to 3 now. Notice that my record is still 3. So the students will complain, hey, I got one right, but my record didn't go up. What you should tell them is, well, there's a penalty, and your score was 2, and now your score is 3. So really, getting that one wrong just forced them to get an extra problem right before they are able to make progress. 4 out of 5. There we go. And then 1. So this one's going to be 5 out of 5. Notice I got a full credit now on this section, and students who make a lot of mistakes are going to be doing more problems because of the penalty, but that's a good thing. Those students need to be doing more practice problems. They need to be making mistakes. So a student who gets this 100% is going to fly through it in a minute, and it will be no big deal. But a student who needs to work on it will be spending the time working on this. If they try to press next problem again, they'll be giving a warning. Hey, you should press back yourself. They can keep practicing. They can do problems as long as they want, and they can get a record of 6 if they want, but that won't affect. The maximum they can get on this section is 25. Okay? So obviously, if I need 100%, I need to go ahead and do them all. But I just want to show you what this looks like from the teacher's perspective. Okay, so you would sign in as your teacher. Okay, I can click student data and problem logs. Now, this is a little confusing. I made a little app to change all my students' names for privacy. So these are just random names right here. But it's very clear that the person we just made right here was Isabella Martinez Aquino. Okay, so this is the most recent 6 problems solved of my students. I can see the time that they solved them. I can see the, obviously the date. I can see their name. I can see whether I got it right or wrong. I can see the assignment name. I can search for all problems from a certain student, Isabella. Well, those are all of hers. So if I choose a random person, I can see all of Brandon's stuff. And this is all from the summer assignment, okay? I can also go through to look at more problems. So this is problem logs. Let me go back to Isabella. Okay, if you want to see the problem, you press view. So you press view, and you see the problem she wrote, and you press next, and you'll see the next one. You press next, you see the next one, and then you press next, you see it was wrong. You see how long it took them, okay? And this is sometimes a little indicator of, you know, if a kid is cheating sometimes. There's, you know, apps like DeltaMath and things that solve problems. And if you see a student solve a problem that should take 5 minutes in 30 seconds, then that's what I do as a teacher is I force that student to submit their notes for all these. That's their punishment. In addition to getting a 0 on the assignment and calling their parents, they also have to turn in all their notes for all assignments. Some teachers are good enough with paper that they don't mind forcing students to turn in their notes for every assignment, but I don't want all the paper. So I would only do that if a student has demonstrated that they were not being honest with their work. Another way of looking at the student data is just to go to view assignments. So if you click view assignments, that's data at the top one. This is probably the main place you would go. These are all my assignments this year as a teacher. I teach pre-calculus, I teach AP calculus, I teach computer science principles. These ones this is the average grade. So these ones are not yet due. So that explains why the grades are so low. These ones were due. So let's look at AP. Okay, if I click my first assignment, right, this is clickable. You click it, you see all the students in that section. Well, there's only 2 sections. There's only 2 students. And you see the grade and the complete. Now, those match. The reason those match is because it's before the due date. So if you ever see complete bigger than grade, it means some of the assignment was completed late, and that was why their grade was docked. It may have been docked fully if you did not have a late date, or it may have been deduct some percentage if you set a percentage for a late date. So you can click that. You can also click the student's name, then you can see their assignment, and you can click the plus and you can see the details. You can also just hover over the checks like this to see how much time it took them. This really shows me, how much effort a kid is putting in. Students will say, oh, I tried it, but I couldn't figure it out. And you'll look, well, look, I don't see any tries here. So there was no tries. So you did not try it, I can see. You can also actually just click this button and sign in as that student. So if a kid say, oh, the assignment wasn't there, you click that and you're signed in as that student, and just like you're them. If you click the edit button, you can edit their name. Let's say they misspell their name. You can change their password, and then you would just type their new password and tell them what it was. You can remove that student if they're no longer in your class, or you can change their class itself. So that's one place you can edit the assignment, edit the student data. The other place you can do that is in Tools. So these are all of my students. Okay, actually, so let's go back here. So let me click on one that has more data. So this is actually data from my AP class. My AP class is very ambitious. You can see they all got 100% complete, but the grade's a little lower. So what happened here? Giovanni, which is not the person's real name, Giovanni got a 94% grade. So part of that assignment must have been completed late, okay? So I can see specifically what they did. If I click, let's say, product rule level 2, then I can see for the whole class how the students were doing. I can see which students was really having trouble. Kelly was really having trouble. So notice she did get 6 out of 6, but she made 7 errors. So an error is not the same as getting it wrong. In fact, these first 2 don't count as errors, because sometimes a student gets one wrong in the beginning on purpose just to get an easier problem. But once they get one right, they don't want to get the next one wrong because there's a penalty. So this is considered an error. So I can see the student really tried. They spent a lot of time. I can look and see. I click that. This is a product rule problem. I can identify that really what the student had wrong was, it's a product rule here, but there's a minus in front of it. So really what needs to happen is a minus followed by brackets or parentheses in the product rule. So this student did not do that, but actually they seem to want to distribute and change that to a plus. Like they learned that mistake, but they still got it wrong because they forgot to take the derivative of x squared. So that should have been 2x. So they did fix one mistake, but they didn't fix both. So it took them 3.8 minutes, but they still ended up getting it wrong. Now, the student is obviously struggling, but I'd say by the end, what happened here? They got 1, 2, 3, 4, 5, 6, 7 right out of their last 8 problems. So I would say forcing them to do 6 and seeing the mistakes that were made, that student is much more likely to be successful. Whereas a student like this, we can see seconds. The student is doing it incredibly quickly because they just get it and they can write down the answer right away. Now, sometimes you'll see a crazy high number like 29.2 hours. That is, all that is the maximum amount of time that it could have taken because it's the amount of time between when they first saw the problem and when they ultimately solved it. So that means if they looked at the problem and then they signed out and went to bed and then signed in the next day and did it, it would say that much time had passed. It's impossible for me to know how much a student is actually working in between, so I just say that. Now, if this says 28 seconds, that's the difference between when they first saw the problem and when they ultimately solved it. If I click there, if I think it's impossible that a student could, write that in that amount of time, then I would think they were cheating. But actually, I think some students can probably just do it as fast as they can type it because they really understand the product rule very well. And I'm sure that's the case with this student right here. Okay, so that's looking at the data. So yeah, you can click on any given section, okay? Now, if we look at one maybe, and you can search for assignment names. So if I say assignment 3, pre-calculus assignment 3. So this is pre-calculus. So you'll see some examples where students maybe didn't do as well. Some kids in pre-calculus aren't doing their work right here. You can click that right there and it sorts it by grade. So you can easily see, you can click it again, it sorts it descending, click it, sorts it ascending. And you can see, okay, these kids didn't do it, so I need to email their house or I need to ask them to stay after school. If I want to just click a certain period, I see, okay, period 2 was 92% complete, period 3 was 90% complete, period 8 was 84% complete. That gives you an idea for that. For the timed one, I did the trig ratios timed here. You can see how many seconds it took them in order to solve trig ratio problems. So this was basically just given a triangle, what's sine of theta, what's cosine of theta, just by looking at the sides, which were already given. Okay, so let's look at a little bit more advanced in terms of what you can do for assignments. I'm going to go to edit. Okay, I'm going to go back to my first assignment. I'm going to go to skills. Okay, so by the way, how did I do that? I clicked create/edit. I clicked edit. And then I clicked from the list which assignment I wanted to edit. Once I clicked that, this assignment came up. And obviously, you might want to change the due date. You might want to change the late credit. You might want to change the skills. But I want to show you about making a mix. So a mix problem is one where it's going to, so I'll show you. So let's say for linear, let's say I want to do mixed equations, okay? So you don't want to assign one like this where it's always additive inverse, because then the kids just know I have to add every time. Part of the trouble might be identifying what kind of problem it is, right? So you may want to make a mixed problem, so mixed equations, and if we click add to mix, now maybe that was a little misleading because I clicked something. By default, when we click mixed problem, we're by default we're able to add to the mix. So I'm going to add to the mix. Notice I'm adding 4 types to the mix, okay? These numbers are the frequency, relative frequency with which they occur. And these have to be whole numbers, actually. So if I want problems that our variable divided by a number to occur twice as often, but all the other ones to occur 1 to 1 to 1, this is the frequency with which those problems will occur in the mix. And I'll make them do 10, for example. Okay. Now, you might also want to turn off show example. That's an option. Turn off show example. If you don't want the students to just press show example every time, if you want to force them to do it without seeing an example, again, it's a decision for the teacher. I'm also going to show you how to add a timed problem. So once I'm done adding to the mix, I have to press finished, because that way I can add other things like this, which would be a totally new skill. Okay, it's not being added to that mix. I could click add to mix, and then everything I add would go to that mix. Okay, but that's not what I want to do right here. Okay, so I'm going to be here. I'm going to get rid of that. You're going to get a little warning. You sure you want to remove it? Yes. So let's add a timed one. So if you add one with a little clock next to it, it means it's timed. So how many do you want them to do? That's in a row. So if I click this, look at the problems. All right, how many of these should they be able to do in a row? Maybe 10, right? You could probably do how fast should students be able to do it? What I do by default is just give a time, such as 100 seconds, and say anything less than 100 seconds is 100% credit on that section. If you want to say, okay, add row, if you can do it in, let's say this, 50 seconds, that's 100% credit. If you can do it in 80 seconds, then that's 80% credit. And if it takes you 100 seconds, then I'm going to make that something else like, let's see, whoops. Oh, never mind, I can't change that one. So that has to be the 100% credit, sorry. And then this is 80, would be 80%, and then 100 seconds would be maybe 70%. So this way it's sort of a scale, so we'll see how that works. Okay, so I've added this. I can click complete. I can go back to my student. That was called test 1016. There it is. All right, so the student will now see, oh, by the way, since I added sections, the grade is recalculated. So the grade has been recalculated in order to say, well, now there's 6 sections and they're all the same. So remember for mixed equations, it was 4 different possible types of equations that could appear. The student is just going to see whatever you called it. So you might also want to make a mix if you want to give it whatever name you want, okay? So if you click it, what we did, we got that additive inverse one, but the student can see that they have 10, and where's that show example button? I don't see it. So that is not there. By the way, for certain types of equations, like quadratic equations, the student might have to press plus, and then they would have 2 answers. So if they ever need to add 2 answers, they would press the plus and add as many as they want, or the minus to subtract. If there's no solution, they would just press minus again. But I'm a little lenient. For example, if they write 3 and then they just press comma key on their keyboard, it just makes a new box. So if they press comma, the assumption is that they're trying to list various solutions, unless it's a point, in which case it sees that there's parentheses. If the student wants to type complicated math, usually if the answer would involve square roots, I would put like a square root button right here, easily accessed. But here they can also do this to sort of type that in. So in this case, what do we see? That's -3. There we go. Now, the next time we get that, but now we get one which is division, right? So we're going to get a mixture, and the students will have practice there. For the time problem, they see time to beat is 50, but they see a little how's my grade calculated. If they want to be able to do in 100 seconds, they'll still get a 70% on that grade, and then that will be averaged in as 1/6 of the assignment. Okay, so we are pretty much done. So I hope you enjoyed the presentation. We know how to look at data. I showed you about 10 different modules that exist, and but obviously there's a lot more, and you have to do a lot of exploring. So I will wait in case there's any extra questions here. So one person says to use this as remediation or in class instruction or in a flipped classroom. So I use it as homework, and that's a personal decision. I use it as homework, but also in class, because sometimes the students are just more motivated if they have the computer and it gives them the feedback and the check, and they want to do well in the classwork grade. When I do it as classwork, I usually add a lot more than is needed, and I don't really grade them on it, but I can see in the class, okay, this group, and I usually pair them, this group of students has only 20% done, so I need to go over to that group and help them out if the majority of the class is 50% done. So I do like to use it in class. It makes for a very enjoyable day. Is it better on Mac or PC? Probably doesn't matter. I am a teacher. I don't have time to test on everything, and I have a Mac. So I always test on a Mac in Chrome. So that's absolutely the best. Okay, so next question. I'm in Texas. I've noticed that when I set a due date and time, it closes an hour early. Okay, so we have made sure their time zone is accurate. Okay, so let me take a look at that. If you set your time zone accurately, it should not be changing the time. Maybe if there's an issue on your computer's clock, I'm not sure. But you can always email me, anybody. The email that you get when you're welcome to DeltaMath, you can reply to that, and I will answer your email. And there's also buttons that show bug report or skill suggestion, and I will respond to those, and I will read those as well. Okay.
Zach, there was one other question on the chat side that asked if the grades can be exported to a standard school grade reporting system like Skyward.
Right. So I would say that that would be awesome, and I should do that, but I haven't done that. I've never heard of that particular system. I will look into possible ways of doing it, but what you can always do is click this button right here, which is download to Excel, and it will download it to an Excel. And there's also options in the teacher page. If you go to school information, you could say require student ID, yes, and then students will be asked to type an ID, and then that Excel document that you download will have the ID. So if you have some other way of matching those IDs to grades, then you might be able to import it yourself.
And then Scott just had a comment that he wished there was a way the grading screen was color-coded for late assignments.
Okay. So I think that makes sense. However, anything that's not 100, I think that's what you mean. Anything that's not 100 is late and should be completed. If it's 100, that means they did it all on time. So that's one way of seeing.
So thank you. If you have any more questions, please put them either in the chat or the Q&A, since I am checking both. Just as a reminder, we will be back next Tuesday at 9 o'clock Eastern. So please join us again. And Zach, this was awesome. This was a lot of information.
Yep.
But really good. So thank you for your time, and thank you for presenting for us.
Okay.
And if there's no further questions, I would like to let Zach go and honor his time because he was amazing. And I will stop the recording.